Hi, how are you? Welcome to this video. Today's video we are going to evaluate this nice integral. We have square root of x over 1 plus x dx. This is indefinite integral and simple integral. So if you take a look at here, you see two functions involved in this integral. You see f of x equals square root of x, and then g of x equal 1 over 1 plus x. So in order to solve this integral, we have only two ways. Most of the time we have by parts and substitution as a variable change. So many people get confused and start working with by part, and at some point they get stuck and come back to the previous form to redo it again, which is kind of wasting the time. Okay, we want to avoid that. I want you to go straight forward to the solution, towards solution. Okay, so in order to avoid these problems, notice here when you see the square root of x and 1 plus x, keep in mind, let's try for example by part. If you take it by part here, you will see, for example, g of x equal 1 plus x. You are going to put this one, for example, as g prime of x 1 over 1 plus x, and then what you do, what are you going to do? You bring this one to the primitive, right, to the origin function, which is natural log of 1 plus x. Okay, because by part is this one. If you're using, like, if you put function, you have u prime and v, right? Let's put u v minus u dv. This is by part, right? For example, you are taking this one as a function, prime function. Okay, then you are looking for the primitive. So g prime of x equal 1 over 1 plus x. This one, it takes you to natural log of 1 plus x. This one you should differentiate, okay, which is 1 over 2 square x. Your new integral become natural log of 1 plus x over 2 times square of x, square root of x. You are going at points which you cannot solve it. You get stuck, okay, because it become more complicated. So why you are doing that? So, and then you are going back to the substitution. So from the beginning we know which way we're taking. Okay, let's start now. Let's do the substitution. Substitution should be easier because our goal to reduce square root of x from the fraction. That's the important thing to do. Okay, let's see. Let's do, for example, you put t as a substitution. Put t equals square root of x. Let's differentiate this one. dt become 1 over 2 square x. Okay, dx. So our dx equal to t dt. You're replacing t by square over x by t, and you will find this one. Let's log in into our integral. Our integral become 2 times t. Okay, another t, don't forget another t of x dt. Divide by 1 plus t square. Because if you raise this one, the power 2 here, you will find t square, you find x here. Okay, your integral become 2t square 1 plus t square dt, right? So I integral become, put 2 outside as a constant. Your integral become 2 square 1 plus t square dt. Take a look at here now. The substitution, you change your x variable completely into a new variable, which is t. You see, your new integral become in terms of t, not x. So what to do now? In order to continue evaluating this one, we should take a look on the bottom, how to make the bottom as the same on the top. Numerator will be equal the denominator. We're gonna add 1, subtract 1. Put 1 plus, minus 1. Like as you doing nothing. So you add in 1, subtract 1 in the same time. So your integral become 2, 1 plus t squared over 1 plus t squared dt plus, don't forget to put number 2 outside, and then the negative sign outside, dt over 1 plus t squared. Okay, this is, you split one integral into two integrals. The first integral equal 1. This one over this one equal 1. 1 plus t squared over 1 plus t squared is a 1. So your integral become dt. The second integral become 2 times multiply into the other one, multiply by 2. So your integral become dt over 1 plus t squared. Okay? This is what is arctangent. This is arctangent. Arctangent x equal from 0 to x dt 1 plus t squared. Okay? This is your arctangent. If we differentiate arctangent, for example, it gives you this one, 1 plus x squared. Okay? So you have to know what's the connection between the primitive and the derivative function. Okay? So this is connection between them. If you want to go back to the arctangent x, you should integrate. If you want to go to the derivation, you should differentiate this function. Okay? So let's continue our integral. Your integral become 2t, because the function, the primitive is 1, is t, minus t arctangent minus arctangent t plus c constant. Don't forget constant c. Okay? And then also, you are not going to leave this integral like this in t term. You should go back to the original function. You have to switch it to x. Okay? Because the original function, it was x, so this integral has to be in x as well. So 2 square x minus 2 arctangent square x plus c, right? So this is your I integral set as I equal this form. Okay, thank you for watching. I see you in next video. Bye.